Good day po, sir. Welcome to Static Routing and Packet Flow. Our group's presentation video will formally illustrate the process of data transmission between a personal computer and the server. The process begins with the user's request on the PC, which is segmented into smaller units called data packets. Each packet contains a portion of the request data, along with the crucial information such as the source IP address, destination address, source MAC address, destination MAC address, source port, and destination port. These packets are then transmitted across the network. Our video will visually depict the packets traversing the network infrastructure, passing through intermediary network devices like routers and switches. Each router examines the DIP within each packet to determine the optimal path for forwarding the packet toward its final destination to the server. Upon reaching the server, the packets are reassembled to reconstruct the original request. The server processes this request and generates a response. This response is then packaged into new data packets with the server's information, IP and MAC addresses and port, now acting as the source and the PC's information as the destination. These response packets then travel back across the network following a reverse path, ultimately reaching the original PC. The PC then reassembles the received packets to deliver the complete response to the user. Now, let's start how PC transfers data to server.
The process begins when the PC wants to send a request to the server. The PC has a private IP address of 192.168.1.100 and a MAC address of AABBCCDDEEFF. The server has a public IP address of 142.250.7278. Since this is an HTTPS request, the PC selects a random source port, which is the 54321 port, while the destination port is 443, which is the standard port for HTTPS. The packet source MAC address is the PC's MAC, the AABBCCDDEEFF, and the destination MAC address is the MAC of the router 1, the 112233445566. Now, when the packet reaches the router 1, it acts as the gateway to external networks and applies the network address translation or NAT. Since the PC has a private IP address, it cannot communicate directly with the public server. So router 1 replaces the PC's private IP, the 192.168.1.100 with its public IP, which is the 203.0.113 and 50. Additionally, it modifies the source port from 54321 to 6100 to keep track of the session. The source MAC address now becomes the MAC of router 1, 112233445566, and the destination MAC address is changed to the MAC of the router 2, which is the 778899123456. Since router 2 is the next device in the path, it receives the packet and forwards it towards the server. It does not modify the IP addresses as it is simply routing the packet. However, it updates the MAC addresses because each hop requires a new layer 2 addresses. The source MAC address now becomes router 2's MAC, which is the 789ABCDEFFAA, and the destination MAC address is set to the server's MAC address, which is the 0123456789AB. The source port remains 61000 and the destination port is still 443. Finally, the server receives the packet and checks if the destination IP address matches its own. Once verified, the server processes the request using the source IP, the 203.0.113.50, and the source port, which is the 6100, to identify the correct session. The server then prepares a response where the source and destination details are reversed and sends it back to the originating PC along the same route.
Now that we've seen how the request travels from PC to the server, let's examine how the response packet makes its way back to the PC. The response follows the same path in reverse, but key elements such as IP addresses, MAC addresses, and port numbers are updated at each step to ensure proper delivery. The server begins by creating a response packet. It sets the source IP address to its own public IP, which is 142.250.72.78, and the destination IP address to the router's one's public IP, which is 203.0.113.50, since that's where the original request came from. The source MAC address is the server's MAC, which is 0123456789AB, and the destination MAC address is router's 2's MAC, which is 789A BCDEFFAA, and the source port is 443, which is the standard HTTPS for the port, and while the destination port is 6100, which was the previously assigned by the router 1 to track the session. As the packet reaches router 2, it is forwarded without modifying the IP addresses. The source IP remains 142.2450.72.78, and the destination IP remains 203.0.113.50. However, since layer 2 communication requires MAC address update at each hop, router 2 replaced the source MAC with its own, which is 789ABC and DEFFAA, and updates the destination MAC to the router's 1's MAC address, which is 778899123456, before forwarding the packet. And next, the packet reaches router 1, where network address translation or NAT is applied to map the public IP address back to the PC's private IP. At this stage, the destination IP address is changed from 203.0.113.50 to the PC's private IP, which is 192.168.1.100. The source IP remains the same, which is 142.250.72.78, because it is coming from the server, and the source MAC address is updated to the router's 1 MAC address, which is 112233445566, and the destination MAC address is now set to the PC's MAC, which is AABBCCDDEEFF. And additionally, the destination port is restored from 6100 to 54321. This is the port originally assigned by the PC when the request is initiated. And finally, the PC receives the response, checks the source and destination details, and processes the data accordingly. The completes the full request response cycle, successfully enabling communication between PC and the server over the internet, with NAT ensuring the private addresses remain hidden while allowing seamless communication with the public networks.
And that is the static routing and packet flow. I hope you enjoy our presentation. Thank you for watching.